Today we are going to discuss the next chapter, and it is the very interesting chapter. The name is fluid mechanics, right? So we are starting with the fluid mechanics. So in the fluid mechanics, we will discuss in a few parts, like fluid statics. First, I will discuss the fluid statics, then fluid dynamics, right? Fluid dynamics. The fluid statics, first we will discuss what does it mean. Fluid at rest. At rest. So we will discuss about the fluid which is at rest and the fluid which is at motion, in motion. Right. The definition of the fluid, first of all, what is the fluid? What is the fluid, you tell? Anything else which can flow, right, is called the fluid. Anything which can flow, is called fluid, For example, water, right? Water, smoke is also be considered to be the fluids. Suppose this is the oil, right? So this is the definition of the fluid which can flow. Everything which can flow is called the fluid, right? So in this case, first definition given in our sheet is the density, right? First I will discuss about the density. Density is nothing but mass. It is represented by rho, and it is nothing but the ratio of the mass per unit volume, right? For example, what is the density of the water? Varsha, it is 10 to the power 3 kilogram per meter cube, right? Or in centimeter, in gram per centimeter cube, 1 gram per centimeter cube. Sometimes it is written as 1 gram per cc, right? Do you know the relation between the kilogram and the meter cube like that? Right. 10 to 3 kilogram per meter cube. 1 meter cube is equal to 10 to the power 6 centimeter cube. You can use the relation. Is it clear or not? For example, the density of mercury density, you have to remember, right? It is 13.6 times the density of the water. You will remember this. Or in 13.6 gram per cc in the CGS unit. This is the SI unit, this is the CGS unit, right? And now if you consider the relative density, what is the relative density? Right. Relative density is nothing but, sometimes the relative density is also called the specific gravity, right? The relative density is nothing but density of the material with respect to water. So density of the material of mercury is 10 to the power 3, 13.6 into 10 to the power 3, and this is water. So this is 13.6. So this is also called sometime specific gravity. You understand? So the specific gravity for the mercury is 13.6. Is it clear or not? Right. For one example, if the specific gravity of oil, they will give the specific gravity of the oil is 8.5. Specific gravity has no unit. You must understand, right? Because this is the ratio of the two density. Find its density. You have to find its density, whose specific gravity is given as 8.5. So what will you do? Please tell. The specific gravity is nothing but density of the material divided by density of water. If you want to find the density of the oil, you can consider this is the oil, right? Specific gravity multiplied by density of the water. So 8.5 into 10 to the power 3 kg per meter cube is the density of this oil. So if the specific gravity is given, you can find the density. Also sometime this term is called the relative density. Then we will use the same definition or the formula to find the density, right? Copy this. So this is the first example I am taking. Suppose we have the sphere, right? And the material, this is the hollow sphere, right? Hollow thick sphere. Here also the material is present from 5 centimeter to the 10 centimeter, right? These are the inner and outer radius. Here is the air, also here is the air, and the total mass is given as it is 2.5 kg. So what you have to find? You have to find first the density of the solid, second the relative density of the solid, right? The relative density, you understand? So how to solve this question? Very simple. Rho is equal to mass upon density, mass upon volume. So what is the mass? It is 2.5. How to find the volume? The volume of the material is 4 by 3 pi r2 cube minus r1 cube, right? So this is the formula. So 3 into 2.5 into 4 into 3.14. What is the r2? This is the r2 and this is the r1. So r2 is 0.1 because it is 10 centimeter, and r1 is what? 0.05 cube, right? So when you will solve this all the things right, so you will get the density 681.2 kilogram per meter cube. So this is the density. And what about the second part, the relative density? Mean the density with respect to water we have to find. The density of the solid, suppose this is the density of the solid divided by density of water. It is 381.2 divided by 1000. 0.68, right, is the relative density for this material. Copy this. Now we will discuss the mixture, right? The mixture. The mixture, suppose if this is the M1 mass, this is the M2 mass, and its density is mixture of liquid, you can say, right? Mixture of liquid. Now this is the M1 and this is the M2, right? Its density is rho1, its density is rho2, right? This is the mixture when they are mixed. So the total mass become M1 plus M2, right? For example, if you mix the water and the kerosene oil like that, or the one oil and the two oil, so what is the density of the mixture you have to find, right? So how to find? For this case, the density of mixture is nothing but total mass divided by total volume, right? So what is the total mass? Say M1 plus M2. What is the total volume? Say V1 plus V2. Is it fine? So in this case, rho1 is equal to what? Say M1 upon V1. So V1 is what? M1 upon rho1. In the same way, its volume is what? V2 is equal to M2 upon rho2, right? So I will put over here the M1 plus M2. The V1 value is M1 upon rho1 plus M2 upon rho2. When you will simplify the rho1 rho2 in the numerator M1 M2, you will multiply M1 rho2 plus M2 rho1. So this is the density of the mixture. You understand or not? That is the thing. All right. Listen one more thing. Okay. If the volume is known to us, for example, if this is the liquid of the volume V1 and this is the liquid of the volume V2, right? Its density is rho1, its density is rho2. Now they are mixed. Fine. So if they are mixed, this is the mixture. So you have to find the density of the mixture. When the volumes we know, in this case, the masses of the liquid M1 and M2 we know, right? Its density is rho1 and rho2. The density of the mixture we have to find. So the total volume become V1 plus V2 and the total mass become mass of mixture, right? So how to find the density of the mixture? Total mass divided by total volume. So what is the mass? Say M1 plus M2 upon V1 plus V2. In this case, we know the volume. So M1 is equal to V1 into rho1. What is the M2? Say V2 into rho2. So I will write M1 value. M1 value is V1 rho1 plus V2 rho2 divided by V1 plus V2. So in this case, the mixture formula when you know the volume of the two liquids, and this is the mixture density formula when you know the masses of the two liquid, right? Copy this. Now in this question, suppose we have the two liquids, right, and the ratio m1 and m2 are given. M1 and M2 are given and it is equal to 2:3, and the density rho 1 is given as 2.1 gram per cc, right, and its density is 0.8 gram per cc, right. So they are asking find the density of the mixture, right. So listen one thing, although I have written these formula, right, but we don't remember after few days, after few week, after few months, we don't remember, but we remember the concept, right. So I'm againing raw mixture is nothing but total mass divided by total volume, right. Mass divided by volume. Listen one thing, so when the mixture is formed, right, mixture is formed, the total mass, the m1 and m2 is given as the 2:3, so I am assuming m1 is equal to 2m, m2 is equal to 3m. I think you understand. So what is the total mass? Total mass is 2m plus 3m, and the volume is v1 plus v2. So what is the volume? V1 is equal to m1 upon rho 1, right. So this in the numerator it is 5m. V1 is equal to m1 m1 upon rho 1 plus v2 is equal to m2 upon rho 2. I think you understand this. Will cancel out. So rho 1 rho 2 is equal to 5 upon 2 rho 2 plus 3 rho 1. Now I will put the value and you will get the answer. 2.5 into 0.8 into 5. 2 into rho 2. Rho 2 is 0.8 plus 3 into, right, 2.5. So answer will be in again the gram per centimeter cube. 8 पंडे 40, 4 25 चौका 100, नीचे ऊपर तो 10 आएगा, and this is 1.6 and this is 7.5. 10 upon 21, right, 8 and 9.1. So little more than, this is 1.09 gram per centimeter cube. This is the density of the mixture, right. Copy this. Although directly you can apply the formula, but sometime it is not remembered, so you will use the concept always. Copy this. Okay, so in this question, right, what we have the two liquid. This is the volume, right, volume v1 and volume v2 are given. The v1 v2 are in the ratio of 3:5, right. So v1 I will write equal to 3v, v2 equal to 5v, and the density rho 1 is given. In this case it is 1.2 gram per cc, and its density is given. This is 1.4 gram per cc. Now when they form the mixture, you have to find the density of the mixture, right, density of mixture. The volume is v1 plus v2, the total mass is m total, which is equal to m1 plus m2. Now m1 is equal to what? Say v1 rho 1. m2 is equal to what? Say v2 rho 2. So what is the density of the mixture formula? You will tell. Density of mixture is nothing but total mass divided by total volume, right. The volume, the v1 and v2 we know, the m1 v1, m2 v2, sorry, m1 plus m2, which is equal to v1 rho 1 plus v2 rho 2 divided by v1 plus v2. The total volume 3v plus 5, right, and the v1 is 3v, the density is 1.2, volume is 5v, density is 1.4. I think you understand. Vv will common, 3.6, 7, and this is 8. So 10.6 upon 8, and when you will solve this, the density is 1.325. So the density of the mixture 1.325 gram per cc, right. This is the density of the mixture. Copy this. Now the very first example I am giving. First of all, the practical data you must remember the density of the ice is less and the density of the water is 1000 kg per meter cube. Although you have to remember in terms of gram per cc, this is 0.9 gram per cc, right, and 1 gram per cc for the water, right. So listen, ice density is less. So if this is the ice, right, and its volume is V1 suppose, so when it will melt and the volume will form, the water will form, so then the volume will decrease. Is it clear? Suppose the mass of the ice is m, so m is equal to v1 into density rho 1 ice you can assume, or the ice volume you can write. But when it melts into the water, right, the mass will be the same, so volume of water into density of water. Is it clear or not? So what they're asking, the mass m is given, so the volume of ice will be more because density of ice is less. M upon volume of ice divide sorry, density of ice, and this is the volume of water, m upon rho water. So volume of ice is greater than the volume of water. So what will be the decreasement in the volume? The decrement in the volume will be m upon rho ice minus m upon rho water. So the mass is common. The rho ice is given as the rho and it is sigma. So this is the answer, right? Copy this. In the next question, this we have the water, right, and we have the another liquid, right, whose density is 2. Listen, the density of the water is 1 and density of the liquid is given 2. What does it mean? 1 is 1 gram per cc, it is 2 gram per cc. The question is little, right, the language is centimeter cube, right. The density of the other liquid is 2, you must understand, and this the density of the water is 1, we know, and the masses are m and the m. So when they form the mixture, you have to find the density of the mixture, right, density of mixture you have to find. So the total mass is m plus m, 2m, right. So how to find the density of the mixture? When the density of liquid 2 and water is mixed, total mass divided by total volume, right. Total mass is 2m, the volume m is equal to v into density of the water, so v1 equal to was mass upon rho water. Mass upon rho water is the volume, and the v2 is equal to mass upon rho liquid. Mass upon rho liquid, fine. So the mm will cancel out to 2 upon 1 upon rho water and 1 upon rho liquid. So this is 1 upon, what is the water density? 1. Liquid density given in the question 2. So what is the answer? 4 upon 3. So density of the mixture is 4 upon 3 gram per centimeter cube, right? Copy this. In the next example, we have the three liquids, and their density is D, 2D, and 3D. Now they are mixed, right? And the mixture is formed. Although the equal volume, the volume of each liquid is what? Same. So what is the volume of the mixture? Say 3V. So you have to find the density of the mixture. Density of individual liquid is D, 2D, 3D, right? So what is the formula? The mixture density is the total mass divided by total volume, right? The volume is nothing but 3V. The mass is m1, m2 plus m3. So how would you write? The m1 is equal to volume into density. The m2 mass, m2 is equal to volume into density. The m3 mass, say volume into density. So what is the m1? m1 is volume into density, volume into density, volume into density. 3V, right? 1, 2, 3. 6V into rho upon 3V is equal to 2 rho. So what is the density of the mixture in this case? The density of the mixture is, I am writing, this is the D, 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 it is D, and the 2D is the density of the mixture, right? So it is not necessary always the two mixture, only two liquid, more than two liquids can also be mixed, right? Copy this. So the next topic is the pressure, right? Density we have discussed, now we will discuss the pressure. Although we have we know this thing, if the some force, perpendicular force is applied to the some area, right, the area is supposed to be A. So what is the pressure? The pressure is the perpendicular force divided by area, right? Although the pressure is what, it is a scalar quantity, and the SI unit is what, you tell. SI unit is Newton per meter square, and this Newton per meter square collectively called the Pascal, represented by PA. Is it clear? Other unit we have also, other unit of pressure. What are the other unit of pressure? First is the atmospheric pressure. Atmospheric pressure, right? Atmospheric pressure. One atmospheric pressure is equal to 1.013 into 10 to the power 5 Newton per meter square, right? This is the first unit. The second unit, right? I think you know the atmospheric pressure in the chemistry. We have also discussed this, right? And the atmospheric pressure is what? The pressure at what pressure exerted by the atmosphere on our body on the surface is this much. Every time this pressure is being exerted by the molecule of the air on our body and everything, right? This atmospheric pressure can also be written in terms of the mercury column, and we will discuss that. 1 atm is equal to 7.6 centimeter of mercury column, right? I will discuss how does it come, or it may be written as 76 millimeter of mercury column, right? So, and what is this is the SI unit, right? Newton per meter square, and in simple it is called the pressure. All right, copy this. So now first I will discuss this pressure. Although there are the three types of the pressure are given, right? Right, types of the pressure. Types of pressure. What are those? First is the atmospheric pressure. Atmospheric pressure, right? Second is the gauge pressure. Gauge pressure. And the other pressure is the absolute pressure. Absolute pressure, right? But I will discuss first the atmospheric pressure measured by the barometer, right? Atmospheric pressure measured by barometer, right? What is the barometer? I will explain. First, copy this. To measure the atmospheric pressure, we use a device which is called the mercury barometer, right? It is also called the Torricelli's right, principle, or Torricelli's law. To use the atmospheric pressure, what is the value of the atmospheric pressure? 1.013 into 10 to the power 5 Newton per meter square. We use the barometer. What is the barometer? Listen, if you take, this is the mercury, this is a tub of mercury, right? This is the tub of mercury. You take, and you take a tube. The length of the tube will be approximately 1 meter or more than 1 meter. And what will you do? You will fill this tube open at one end full with mercury, right? This is the mercury is filled. What is the density of the mercury? You know? Yes, you have to remember 13.6 into 10 to the power 3 kg per meter cube. All right. So when you fill with this is the tub of mercury. This is also the mercury, 1 meter long tube open at one end. What will you do? To measure the atmospheric pressure, and this is called the Torricelli's experiment, and this setup is called the barometer. By barometer, right? This is the barometer. What will you do? You close this end and invert this, and you will dip in this mercury tub, right? So what will happen? So this is the, you may write it later, right? What will happen? this is the mercury tube, the mercury tube, the tube full with mercury. So when it will fall down, so there will be some decrease in the level of the mercury column like this, and because it is closed at this end, so no air is present over here, so the pressure at this point is zero. You understand? And the level is found when you measure this level. When you measure this level, the level comes to be 76 centimeter. Is it clear or not? And this is the atmospheric pressure. This is the atmospheric pressure over here, and this is also the pressure P. So in the same horizontal level, this is the point 1, this is the point P, point 2. Because at the same height, horizontal level, the pressure must be the same, right? So the point 2 pressure must be equal to the point 1 pressure, right? I will discuss this also. How does these pressure are equal? But now you may assume that at the same horizontal level, the pressure must be the same, and it is open to air. So what is the pressure P1? Is the pressure of the atmosphere, right? This is the pressure of the atmosphere. What is the pressure P2? Right? If this is 0, when you will come down, the pressure is increased. So the H rho G, the pressure wide liquid column is equal to H rho G. If you don't know, I will explain this also. But due to the pressure, due to the liquid column, the pressure is H rho G. What is the rho? Rho is the mercury into G is the density. All right. This density. So now we don't know the pressure. So what to do? The pressure, atmospheric pressure is equal to H rho mercury into G. What is the height of this column measured by the meter scale? It always comes to be 76 centimeter. Whether you take the tube 2 meter long or 1.5 meter, when you invert this into this mercury tub, this mercury column is balanced always 76 centimeter. So if you put the value of H rho and this is G, then you will get the pressure at this point, which is nothing but equal to the atmospheric pressure. So the atmospheric pressure is 76 centimeter. You will put in the SI unit the density of the mercury, right, and the value of the G, right. So what the pressure at this point 1, which is equal to the atmospheric pressure, when you will calculate, it comes approximately this much, right. So using this barometer device, right, we can measure the outside surrounding pressure, which comes to be like this in our on our physics lab, right. Wherever you perform this experiment, this height always comes to be 76 centimeter. So that is why the pressure, atmospheric pressure, sometime it is called the 76 centimeter. Wait for 1 minute. I have made a mistake. This is the 76 centimeter of mercury and 760 millimeter of mercury column. Please make it correct, right. So this is the 76 centimeter mercury column equal to the atmospheric pressure, we can also say, right. So 1 atm pressure is nothing but 76 centimeter of mercury column, 760 millimeter of mercury column, or it is 1.013 into 10 to the power 5 Newton per meter square, and this is measured by the barometer. Sometime it is also called the Torricelli's experiment, right. This is the thing. Calculate this, copy this. So I will explain this gauge pressure and absolute pressure, but first we will discuss the important topic is that the variation of pressure due to depth, variation in pressure due to depth, right, due to depth. All right, how it is? Suppose there is a liquid, right, this is the liquid, and in this liquid, when we move down, the density is rho of the liquid. When we will move down, the pressure will increase or decrease, you tell. If this is the point 1 Varsha and this is the point 2, the pressure will increase or decrease? The pressure increases. How it is increasing and by what amount it is increasing, we are going to discuss the variation pressure due to depth, right? For example, if you consider the 2.1 and 2 separated by the depth h, right? To find the pressure difference, the pressure P2 and P1 you have to find. To do that, you to find this, you have to consider a cylinder, suppose, right? The cylinder, and this liquid is in rest. I'm considering we are discussing the fluid at rest, the fluid statistics we are discussing in the very first part, right? So if this liquid is at rest, so this liquid column will also be in at rest. You understand or not? So if you consider the length is h of this liquid column and it is in equilibrium, if this is the area A and the pressure at this point is P1, this is the area A, the pressure at this point is P2. So what is happening? The pressure is this P1, the force F1 will be acting on this side, the force F2 will be acting on this side, and what is the mass? The total mass mg will be acting this side. If this liquid column is in equilibrium, for equilibrium, what will be the relation? F1, F2 and mg you will write. The net downward force F1 plus mg must be balanced by the upward force due to the pressure P2. Is it clear or not? So what is the pressure P1? If the area is A, pressure is equal to force upon area. The pressure P2 is equal to force upon area. So F1 is what? Say P1 into A. The F2 is what? Say P2 into A. Is it clear or not? So the F2 minus F1 is equal to what? Say mg. What is m? The mass of this liquid column. The F2 is P2 minus P1 into A is equal to m into g. What is the mass of the liquid column? Say volume, its total volume of cylinder into density, density of the liquid. What is the volume? Say area multiplied by h into density. So I will put the mass is equal to AH into rho. It will cancel out. Is it clear or not? And this is the G. This is the mass into G. Area will cancel out. So what is the change in pressure? H rho G. So this is the pressure I have used over here. The pressure formula when we will move down is equal to H rho G. So at this point pressure P2 will be equal to, right, P2 minus P1 is equal to what? H rho G. So the pressure P2 is greater than the pressure at point 1 by the amount H rho G. You understand or not? Copy this. So this is the pressure variation due to the depth and the formula is H rho G. For example, suppose this is the liquid, or you can assume this is the sea or the river, but the river is flowing, so we will consider the sea level or the water filled in the pond, right? If this is the water filled, right, the density of the water you know very well, kg per meter cube, and the atmospheric pressure is P naught, although the value of the atmospheric pressure is 1.01 into 10 to the power 5, but sometime it may be assumed to be 10 to the power 5. So atmospheric pressure is given over here. So if we move down by the 1 kilometer, right, the H rho G, right, the 10 meter if we go down, so what is the pressure at this point? From the surface of the water, if we go down by the depth 10 meter, what will be the pressure at this point? So how would you find? Listen one thing. If you consider the any 2 point and depth is h, so as we go down the pressure will increase. By what amount it will increase? H rho G. So P2, if you consider this the P1, so P2 minus P1 is equal to what? Say H rho G. And therefore the P2 at this point, pressure at this point 2 is equal to H rho water into G. What is the pressure P1, which is equal to the open area, open surface pressure, which is equal to the atmospheric pressure. The depth is what? Say 10 meter. Density of the water, G I will assume also equal to be the 10. Right, although if the different data is given, you can use that, plus 10 to the power 5 So the pressure is 2 into 10 to the power 5 Newton per meter square. You understand this thing or not? Yes. So this is the pressure, right? The raw water is 10 to the power 3 kg per meter cube. Now listen one thing. As we go down, the pressure is increased by H rho g. Now this is the atmospheric pressure we have done. What is the gauge pressure? I am writing the definition of the gauge pressure. What is the gauge pressure? Varsha, right? The gauge pressure is nothing but the excess pressure, right, other than the atmospheric pressure. Excess pressure above the atmospheric pressure. Atmospheric pressure is called the gauge pressure. For example, if here is the P2, and this is the P2 is equal to P naught. So what is the gauge pressure at this point? The excess pressure P2 minus P1 is equal to H rho g. So this is called the gauge pressure. The excess P2 minus P naught is equal to H rho g. So above than the atmospheric pressure, if we move down, the pressure will increase. So that this is the and what is the absolute pressure? Third, this is the gauge pressure, and what is the absolute pressure? Absolute pressure is nothing but the total value of the pressure at point P, right? Absolute pressure means the pressure at that point. Exact pressure at that point. That's simple. At that point. So what is the absolute pressure? Here the absolute pressure is P naught plus H rho g. So what is the gauge pressure? This is the gauge pressure in this case, the excess pressure above than the atmospheric pressure, and the exact pressure at this point is called the absolute pressure. And what is the atmospheric pressure? The atmospheric pressure is nothing but the pressure exerted by the atmosphere. That is the thing, right? So atmospheric pressure, gauge pressure, and absolute pressure, the definition are simple. Also given your study material, you can go through the same definition and the same explanation you will get, right? Copy this.